Hello everyone. So after 2 week, I am starting the class. I was very busy during the election time. So I think in our last class we have completed the Bolzano-Oester's theorem, which is very important. Okay, and we have seen some problem. Now today we discuss the limit inferior or limit superior. Okay, so limit superior. Okay, so in Bolzano-Oester's theorem, what you have seen that if you have a bounded sequence, that you have a convergent subsequence. Okay, so if you have a bounded sequence, suppose un, so then obviously there will be some subsequential limit. Okay, then suppose L1 is a limit, L2 is a limit, like that. Okay, among all such limit, which is the greatest, that will we say upper limit or limit superior, and which is the least one, that that will say limit inferior or lower limit. Okay, so let xn be a bounded sequence of R, and the greatest subsequential of xn is said to be the upper limit or the limit superior of xn. Okay, and it is denoted by lim, then you have a upper script un. Okay, or sometime it is written like lim superior, so from that lim sup, sorry, this is xn, right? So this is the definition for limit superior. So similarly, if you write the opposite, okay, okay, so the greatest, instead of greatest you have the least, right? The least subsequent limit of xn is said to be the lower limit or the limit inferior of xn, and it is denoted by limit infimum of xn. Okay, now suppose you have some sequence, for example, if you consider this example, minus 1 whole to the power n into 1 plus n. Okay, so if you think what is the limit of that, okay, so you see this will be positive if you take n is like some even number, so from there it is clear that the upper limit will be 1, right? And if you take some odd number, so then it is like some odd number, that 1 by 2 n plus 1 like thing. Obviously this number going to 0, right, as n tending to infinity. So from there you will get this limit is 1, and but in the outside you have minus sign, so from there you have the limit inferior is minus 1. Okay, so think this type of problem, this is your minus 1 and limit supremum is your 1. Just how you are considering this, if you consider n is equal to 2k plus 1, if you consider this subsequence, from there that limit subsequence limit is minus 1. N is equal to 2k, this one. Obviously there is only these two sequence that are convergent. Okay, yeah, if you consider n equal to 4k or 8k, that does not make any sense, right? That are the subsequence of that one. Okay, so after that we go to the next part. Yeah, so remember, if your sequence is convergent, then your limit supremum and limit infimum, that will be convergent. Okay, okay. Okay, before that there are some epsilon definition of this limit supremum and infimum. Okay, so let u star be the lim, so okay, write it extra of xn, then two condition satisfy. Have condition condition for any epsilon greater than 0, you have so basically you can think your xn is like here in such a way. Okay, then you have the x star is like somewhere here, right? So xn will be greater than x star minus epsilon for infinitely many values of n. So basically if you have this thing, so if this is x star, so if you consider x star minus epsilon, so here basically infinitely many values of n is there, for which you have your xn will be greater than that. Okay, and second thing is your xn will be less than x star plus epsilon this will happen for all except few. Okay, so basically there exists a k belongs to natural number n such that xn will be less than x star plus epsilon for all n greater equal to k. You see, this is also infinitely many, right? Because if you consider n greater equal to k, how many number is there? Obviously that is also infinitely many, but this is, you can say, k plus 1, k plus 2, right? For all the consecutive number this is happening, but here this is not the same thing. Here you can say this is happening for suppose all the even number like 2, 4, 6, all the thing. So you see this is not consecutive, but this is consecutive. So this is the difference between these two statements. So whenever you have x star, so x star minus epsilon, xn will be greater than that number for infinitely many. Okay, and x star plus epsilon, this is x star minus epsilon, so x star plus epsilon may be this side. So this is happening for all except few. Except few means what are the number for which this is not happening? For 1, 2, dot 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 k minus 1, right? So except this number, for all others number, this statement is satisfying. Okay, so this is the definition. Okay, now similarly if you trying to write for limit infimum, so what is happening here, this will be like, this is suppose x lower star, so this is your x star plus epsilon, this is your x star minus epsilon, right? So your basically xn will be in this way. So this will be changed by x star, xn will be greater than x star minus epsilon for all n greater equal to this, and xn will be less than x star plus epsilon for infinitely many this thing. Okay, so in this way you have these two things. After that you have a theorem. This is your homework 1. This is easy. Using these two definition you have to do this thing. Okay, so a bounded sequence, so you can say whenever you have some bounded sequence, then your limit infimum and limit supremum is exist, right? So a bounded sequence is convergent if and only if limit xn equal to limit xn. So this is your homework. Okay. Okay, you can note this type of point, that if you have limit supremum of un plus limit, so if you have two sequence un and vn, then this will be less or equal to limit un plus vn. Okay, and this is for not for your NBU exam. This is for, you can, if you gives any competitive exam like JAM and later on GATE, So then this type of theorem is important. Okay, so you can make a note. So how this type of question is asked, suppose they will give you which of the following is true, then option 1, option 2, option 3, option 4, this type of sign they will change. Okay, then you have to see the answer. Okay, so you see here, if you consider their sum and if you do the limit supremum, then that will be larger. Okay, so there is an example. If you consider that, suppose they ask, give an example where limit un plus limit vn is strictly less than limit un plus vn. Sorry, I changed the sign. Basically this is greater equal to, so you have to give example where this inequality is strict. Okay, so for this one there is an example that suppose you have un is equal to sine n pi by 2. Okay, and vn is equal to cosine n pi by 2. Okay, so what is your limit un? Value this will be 1, right? And what is limit vn? This is also 1. But if you consider limit un plus vn, you just try to do this, just for example n is equal to 1, what you are getting, n is equal to 2, what you are getting, and then try to find the limit. So you will get this is also 1. So here you are getting 1 and here it is 1 plus 1. So obviously this is happening, right? So in this way you have this thing. Okay, so these are for your advanced level. Now we'll discuss the Cauchy criteria. Okay, let's discuss the this is also a convergence criteria. Like if you have a sequence xn which is converges to L, means what? So basically for any epsilon greater than 0 there exists a k for which you have xn minus x star, this is less than epsilon for all n greater equal to k, right? This type of theorem you have, right? Now if you don't have this limit, then how you can say your sequence will be convergent? So that there is a role of this Cauchy criteria, or later you will learn that whenever you have a sequence that satisfies the Cauchy criteria, that sequence is called actually Cauchy sequence. Okay, so first write this thing. So Cauchy criteria, actually you have an important theorem. A necessary and sufficient condition for the convergence of a sequence xn is that for a pre-assigned positive epsilon there exists a natural number m such that x of n plus p minus xn that is less than epsilon for all n greater equal to okay, we actually comfortable with k, n greater equal to k, and p equal to 1 2 3 dot. Okay, so basically you can say for any epsilon there will be some k for which your p value you can choose accordingly. So you can say n plus 1 minus xn this is less than epsilon, or xn plus 2 minus xn that is less than epsilon, in such a way. Okay, so this necessary and sufficient means this is if and only if. So if your sequence xn is convergent, if and only if you have this result. Okay, so this is theorem you have to prove, and this is very very important also. Okay, so first consider the case when your un is convergent. So then you have to prove that this condition is satisfied. Okay, so let xn is convergent. To L. So what do you mean by that? For any epsilon greater than 0 there exists a k belongs to natural number n such that xn minus L this is less than epsilon for all n greater equal to k. Okay, we will trying to do it Sn by 2. Okay, so this is happening for all n which is greater equal to k. So if I write instead of n plus p, that is also satisfied, because if your n is greater equal to k then n plus p that is also greater equal to k, right? Because p value is your 1 2 3 like that. Okay, so therefore you have xn plus p minus L this is also less than epsilon by 2 for all n greater equal to k, and p equal to 1 2 3 dot dot dot. Okay, now if you start from there, that xn plus p minus xn, so this is will be less or equal to x of n plus p minus L plus L minus xn. So this thing you can write as x of n plus p minus L plus xn minus L, so less than epsilon by 2 plus epsilon by 2. This is using triangular inequality, right? Yeah. Okay, fine. So you have proved this thing, so this proves that the condition is necessary. Now you have to prove the sufficient, that if your sequence satisfy this criteria, then it is enough for the convergence criteria. Okay, so this is sufficient. Okay. So this part, basically this is your this part. Okay, so you have this condition, right? For any epsilon greater than 0, there exists a k belongs to natural number n such that for which you have n plus p minus un, this is less than epsilon for all n greater equal to k and p equal to 1 2 3 dot dot dot. So you have this condition in your hand, but you have to prove this is x, xn is convergent to some number l, but this is not provided. Okay, so how I get that number l? So for this one, how you have to construct? First you will show that your sequence xn is actually bounded. Okay, so using first we will show the bounded sequence, then whenever you have bounded sequence, it has a convergent subsequence. By what theorem? Bolzano-Stars. So you have a convergent subsequence, so it has a subsequence, you can say xnk, that is converging to l, right? Now your goal will be this l will be the limit of the main sequence. Okay, so in this way you have to prove. This is a little bit large. Okay, so let's prove this. So let epsilon equal to 1. So then there exists k. I am writing this k. Okay, same k, or we can write some maybe m, no issue. Just okay, write k1 belongs to natural number n such that what is happening, that xn plus p minus xn, this is less than 1 for all n greater equal to k1, right? So if you break this mod, so this imply that xn plus p will be lying between xn. Okay, in particular if you p equal to 1 2 3 dot dot dot. Okay, in particular if you put that value k here, so you have xk plus p minus xk, right? You can write in particular k will be better, k. Okay, or write m particular okay. So xm is some fixed number. Right? So you know how to prove that type of bounded. Earlier also we have done, right? So let b equal to max of x1 x2 dot 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 xm minus 1, and so after onwards xm. Okay, so whenever your this m plus 1 m plus 2 that are in this bracket, right? So if you consider this one, so that will be the upper bound, and if you consider the b equal to mean of same thing, this thing already we have done earlier also. So your xn is less or equal to b and greater equal to small b for all n. So you have xn is bounded okay by Bolzano Weierstrass theorem. Xn has a convergent subsequence say okay convergent subsequence, right? Let L be the subsequential limit. So let epsilon greater than 0, then by the given condition m such that here will start from epsilon 3. Actually all k m all are similar type of thing. Earlier what we have written, first line you have written epsilon for k, then you have a used m thing. Okay, so I am writing maybe r, no choice, and p equal to 1 2 3 dot dot dot. Okay, so in particular if you consider that your n equal to r, So r plus p minus xr less than epsilon by 3. Okay. Now since L is a subsequential limit of xn, so you know each epsilon neighborhood of L contains infinite number of elements of xn this is your earlier theorem, right? So there exists a q belongs to natural number such that q is your greater than m, for which you can say xq minus l, this is less than epsilon by 3. Obviously we will get some q for which this is happening, because like you know that nk type of thing, this nk is also a subsequent strict subsequence of natural number, right? So during using the strict property, obviously there will be some number will be greater than m, right? So you have this thing. Okay, now you come to this point. Okay, since you have q greater than m, sorry, not m, this is actually r we have used. Since your q is greater than r, so what you have, xq minus xr will be less than epsilon by 3. Why we can say this? Because if you say this type of thing, n plus p minus n, p can be any number, right? Maybe suppose q is like r plus 3, so your p is working as your 3, right? So now come to this point. Now if you consider xr plus p minus l, so this is less or equal to, you can say, xr plus p minus xr plus xr minus xq plus xq minus l. We can break this now using triangular inequality. Therefore you see this r plus p you can treat as your some new variable, right? So therefore you can say xn minus, so this is your epsilon, right? So you can choose your n is like r plus 1, right? Since epsilon is arbitrary, and you know this is the definition of your convergence, right? X(n) is convergent. That's it. Okay. So this criteria is called the Cauchy condition. Okay. So after that you have a definition, your Cauchy sequence. A sequence xn is said to be Cauchy if for a pre-assigned positive epsilon, or you can say just for any epsilon greater than 0, there exists a k belongs to natural number n such that you have xm minus xn, this is less than epsilon for all m and n greater than equal to k. You just observe this thing, that this m and n if you write, and instead of that your k plus p minus xk, these are the similar thing. Here you are using two variable m and n. You are not giving that which is larger. You see m and maybe you have m is lower, but you have the modulus thing, right? So a similar thing here also. You see here you have written that xn plus p minus xn. So what are their condition? That one number will be greater than other, right? N plus p is greater than n. Okay, but if you write instead of that modulus of xn minus xn plus p, this is the same thing, right? Because you have mod, and instead of n plus p, if you write that n plus p is your m number, is there will be any problem? No problem, right? So you can write in this way. So this is the definition of Cauchy sequence. Okay. Example. One by n, so that 1 by n is a Cauchy sequence. Okay. So you start from xm minus xn, right? So this is equal to 1 by m minus 1 by n. So this is, if you break, you have 1 by m plus 1 by n. Okay, this type of thing. So let, if you consider m greater than n, so if you consider m greater than n, so then your 1 by m will be less than 1 by n, right? So from there you can write this is your 2 by n type of thing, right? So let m greater than n, then you have this type of thing. So this will be less than epsilon when what? N will be greater than 2 by epsilon, right? So how to choose that k? Choose k equal to box of 2 by epsilon plus 1. This type of thing already we have done earlier. So if you choose this thing, so for this one what happened? Xm minus xn will be less than epsilon for all n greater equal to k. Alright, so in this way you have this thing. Your homework 2 is one by n square plus 1 is Cauchy. Homework 3, this is the theorem. This theorem already we have discussed. Okay, you just have a look in the schema of a book, that a Cauchy sequence of a real number is convergent. Similar type of proof, must have a look in the, and this is very very important. Okay, so I stop the class here. We will take one more class on the sequence, then we start the series. Okay, bye.